Hi, in this video I want to talk about magnetic contacts. Magnetic contact is the most common device used in alarms. It can take different shapes. It can be built into another device. That's the most simple contact. So you have a magnet, an actual contact with 4 wires. When you get a magnet to the contact close, very close, the contact is closed. When you take magnet away, contact is open. You can see 4 different wires, because 2 wires are alarm, so it's actual contact. Don't remember now which one, probably this one. And 2 wires are tamper. And I explained already what tamper is in other lessons, but I can repeat it. So basically tamper is to protect somebody from tampering. So if somebody would cut this wire, will cut those tamper cables, and it would cause tamper alarm. That's another heavy duty contact, and you can see those wires are the same color, and that's on purpose. Higher grade alarms shouldn't have multiple colors, should have every single wire in the same color, because then whoever would get into those wires, he wouldn't know which one is which. There's no way of knowing. And principle is obviously the same in every contact. This or this, you have an actual contact, and then you need a magnet which will trigger that contact. You can have even that heavy magnets, big. It's for roller shutter contacts, which are big and heavy metallic. You can have those tiny contacts, or you can have contact built into the shock sensor. Quickly open that shock sensor so you can see that there is a contact inside. So it's another very typical device for houses. That's your shock sensor, which I explained in another video. That's your tamper switch, and there is a tiny element there which is a contact. When you get a magnet close to it, it will close the contact. If you take magnet away, it will open. It's a delicate tiny device, but it works. So basically, as I said, that's the most common device. You see them on doors, windows, some other places like on the door of the safes, everywhere. Now this one, as you can see, I wired all those 4 wires to this block connector. You can forget for a moment about those resistors. So there are 2 wires here, and one disconnected. So I have to screw it back, hopefully. So one of those, so 2 wires will be alarm, and 2 wires will be tamper, as I explained just a second ago. And because you have the same color, you don't know which one is which. So how do you find out which one is which? You measure them. So if your contact has no magnet beside, 2 of those wires will have no connection between each other, and between 2 of them there will be a short, because that's a tamper. The tamper wire will go inside the closed loop and will come back. So if you measure tamper wire without the contact beside, you will have a connection. So as you can see, I already wired those wires to the connector. That's my continuity setting on the multimeter, and I check those 2 wires. Perfect. It's only perfect because I already found which one is which. And this is alarm wires, sorry, 2 of them. Nothing happens, yeah. Also, there shouldn't be any connection between tamper and the alarm. So you can check alarm, tamper with each particular cable. So the only connections there and there's alarm. So just to prove the point, since this is tamper and this is alarm, so there is nothing there because there is no magnet, I will just move closer that powerful magnet. It's a huge magnet. Okay, put it there, and let's see what happens on the wires, alarm wires. Oh, working. If I move it away, maybe I can do this live. So we have those two wires. I'm connected to those two wires. Yeah, move away, closer, away, close, away. And that's how contact works. Every single one. They may, as I said, they may look differently, they may have different shapes, like heavy duty roller shutter I don't have here, it's bigger than that. It's also metallic, bigger, so the forklift can actually drive over it. Or you can have tiny like this, or tiny like this. It will build into another device, typically into the shock sensor. So another thing which is important, so we already know how to find which wires are tampered on the contact, simply by using multimeter when contact has no magnet beside. And that's how you find out your tamper wires and alarm wires. And then you can additionally test your alarm wires to see if they're actually working. And that's how you test also contact. If you have a problem with the contact, you put a multimeter in and you check if you get magnet close, if it's working or not. Could be all kinds of faults, could be broken inside, wires could be broken. A lot of different faults can happen in alarm systems. What is important now, the most common way of connecting any actual device to the alarm panel is so-called dual end of line connection. And I already prepared two resistors in here. So remember, this is our alarm and this is our tamper. So as you can see the way it is connected, maybe just say a few words first about resistors. There are in different alarm panels, they may require different resistors. Those two resistors are 2K2, so 2200 ohms. Some panels use 4K7, which is 4700 ohms. Other panels like Galaxy, that's a keypad from Galaxy, use 1K, which is 1000 ohms. Some panels you can switch, also in Galaxy, in HKC, many different. You can change what resistors you want to use with that panel. But there are those typical ones, which is 2K2, 4K7, 1K. They're the most common ones. So again, I already prepared the connection. So you have to connect it to the panel. The reason for using dual end of line connection, the main reason is because you can do this with two cables only. So you have this here device which is there, so that's your alarm switch, that's the resistor connected in parallel with the alarm. Then you have a resistor in series with the tamper, so from the alarm goes resistor into the tamper, then goes through the tamper and to alarm panel. So you have only two wires. Why it's important to have two wires? Because very often when you're using other types of devices, you need to also send power. So for instance, where's my PIR? Oh, doesn't matter. There's a very old that's very old Dualtech, so it's using more microwaves and it requires power. Any PIR or motion detector or keypad requires power. Very often on the alarm cable, that's an example alarm cable, you have to send two devices at the same time. And if you're using dual end line connection like this, you can do that because you have 8 cables, 8 cores, sorry, 8 wires, 8 cores, yeah. So you have 8 cables there, tiny cables. So you can use 2 cables for one alarm device, 2 for another, and you still have 2 and 2, one power for one and power for another. Another reason for that is, even if you don't use for another device, you have another spare cores inside the cable. Why is this good? Because sometimes cables break, sometimes something happens. Somebody will do some work in the building and will punch on one of those wires somehow accidentally. And you will need to swap those wires. So that's why you're using dual end of line. One of the reasons, obviously. Because you can save on the cable and you can spare wires for either other devices or just to have it spare. So a nice and colorful wires in alarm cable. Alarm cable doesn't have to be brown. Typically it's white. I actually have brown at the moment, so it doesn't really matter. We have all colors here. Typically red and black, blue and yellow, green and brown, white, and I don't know what this color is. This typical color. What colors you use for what? There's no rule whatsoever. Colors you're using are those which you always use, so they are consistent. Like if you're making installations, use always the same colors for the same thing. So if you're using power for PIRs and motion detectors, red and black, you keep using that. If you're using, let's say, alarm blue and yellow, you keep using this all the time. You don't change it. So different different companies will have different rules, which colors are for what. All you have to do is just be consistent. Doesn't matter which is which, as long as you're consistent in all the installations, and especially in one particular installation. So, since I explained it, so again, how exactly dual end of line works. So this is connected to alarm panel, and so you have an alarm switch which is normally closed, and tamper which is normally closed. So usually it's closed. So we have a resistor in parallel with the alarm, which means when the alarm is not in alarm, so it is closed, this resistor is shorted. So it's not visible. So basically it's just like that. So if alarm is closed, which means device is not in alarm, all what the panel will see is this resistor, because tamper will also be closed. And not because it's not in alarm, just tamper opens when you break the cable, when you cut the cable, or when you open housing, like on this device, that's a PIR, there's a tamper switch here. When you open, it opens that. It's the same for every device basically. So again, when there is no alarm, this is closed, so this resistor is shorted, it's not visible. So the current will go through this contact, alarm part, through this resistor, through this contact, and back to panel. So there is no alarm and tamper is not open, panel will see just this resistor. And that's how panel knows that's normal state. If alarms goes off, this opens, so panel will see this resistor and then this resistor. So we'll see, like if you were using, let's say, 2K2, so if alarm goes off and tamper is closed properly, we'll see those two resistors, so panel will see 4K4, 4400 ohms. If there is no alarm, we'll see 2200 ohms, assuming we're using this 2K2 resistor. If there is no alarm, but there is a tamper, what the panel will see just break. break of the circuit. So we won't see those resistors, we'll see just the circuit is open, it's break. And there will be a tamper alarm. So basically we have those three states: normal, alarm, and tamper. Because even if it's alarm and it's tamper, it still will see tamper only, because this basically breaks off the entire circuit. And that's how it works. It's very simple. And we can demonstrate this here. So we have those, you see those two resistors. We have our multimeter. There are 2K2. Move here. So I move my multimeter to 20K range. There's no contact, no magnet. So alarm is open. Yeah. This is one side of the tamper, and there is one side of the alarm. What do you see? 4.4. Well, obviously there's some tolerance there. So there's 4K 4400 ohms, because there's no alarm. Sorry, there's alarm and tamper is okay. Yeah. If we close the circuit with the magnet, and what happens? What happens? This is shorted. No, something happened with the multimeter. Don't know what. Maybe battery. I'll turn it off, turn it on. This works. Again 20K. And again we go with full circuit. Yeah, 4K 4400, 4K 4 ohms. And if we get a magnet close to that, what do we get? 2K2 2200. So as I explained, when the alarm circuit is closed, so there's no alarm, panel will see only that resistor which is in series with tamper. If the contact is open, so it's in alarm, panel will see 4K, and again something happened here, 4K 4. So we see both resistors at the same time. And that's exactly how I explained it works. When the alarm is closed, this resistor is shorted, and panel sees only this one. If the alarm is contact is open, panel will see those two resistors. If tamper is open, panel will see just open circuit. And basically that's all about contacts. Obviously you need magnet to make it work. It has to be at certain distance, not too far. There are third grade, so there are different grades of the alarm systems. Typically most installations are second grade. On a third grade, devices are more precise. For instance, on a third grade, contacts cannot be too far or too close with the magnet. And this wouldn't be third grade because it should be tampered. All the wires should be the same color, and there should be tamper on the back, so you cannot take it off. And then working distance between those two is precise and limited. But that's about third grade alarms. And basically it's all about contacts, and the next one probably will do PIR. Thank you.